In electrical measurements, we covered first unit, second unit, and fifth unit and fourth unit, except second and third units. Briefly, what is unit 3? What are the important topics? Similar to that, how to write the examination, then how to get more marks in unit 3 and unit 4, as well as remaining chapters also. I explained one video, but unit 3 is measurement of power and energy. What is power? Power is energy transferred over a period of time is known as power, because the energy is defined as power into product of power and time. It is energy. The energy is defined as power into time is nothing but power consumed over a period of time is called as energy. Energy equal to power into time. That is, power is measured in kilowatt, or time is measured in hour. What is the unit for energy is kilowatt hour. What is the unit for power is kilowatt. From this equation, power equal to energy by time. Energy delivered over a period of time is known as power. Power also we can calculate by using voltmeter reading and ammeter reading in case of DC circuits. If you multiply voltage and current, you will get power. But in case of AC circuit, power factor also will come, cos phi. It is single phase. For three phase, power in three phases root 3 VI cos phi. VL IL cos phi. It is the power in three phases VL IL cos phi, where IVL, IL is line voltage and line current. Similarly, power also can be expressed as we can express the power also in terms of V phase, I phase. Power in three phase is 3 V phase, I phase cos pi. That is power in three phase, 3 V phase, I phase cos phi. What is the unit for power is, everybody knows that kilowatt is the unit for power, whereas a unit for energy is kWh, kilowatt hour or watt hour. How to measure power? As the name says, unit of chapter is measurement of power and energy. How to measure the power? By taking the voltmeter, one voltmeter and one ammeter, we can measure the power. We can measure the power by taking one voltmeter and ammeter connected across the load. We can measure the power by that method is known as voltmeter ammeter method. In voltmeter ammeter method also we can use to measure the power, but some errors will come because of voltmeter. Not only, suppose if you connect voltmeter like this and ammeter like this across the load, then some errors will introduce, because the voltmeter not only reads the voltage across the load, but also what is the voltage drop across ammeter. What is the voltage drop across ammeter also the wattmeter reads. Hence, measurement of power with the help of voltmeter ammeter method gives some losses. Suppose if you connect ammeter starting, if you connect ammeter at the time of starting, if you connect ammeter here and voltmeter here, if you connect ammeter and voltmeter and load, it is a load, assume that raised to load or inductive load or whatever it is, assume that it is a plus or minus. Ammeter current, not only load current, IL is the load current, and this is voltmeter carries some current. Ammeter not only reads the value of load current, but also it reads the value of voltmeter reading. Hence we go for wattmeter. Instead of losses will come here, ammeter not only shows the load power, but exactly what we need to measure the power, what is the power consumed by load. But voltmeter ammeter method doesn't give accurate value to measure the power. Hence we go for wattmeter. That means power can be measured by wattmeter. How to measure the electrical energy? What is meant by energy? Energy is integral 0 to t power into dt. That is power consumed over a period of time from 0 to time t. What is the power consumed? That is known as electrical energy consumed. Electrical energy. How to measure the energy is by using energy meter. Energy meter measures the electrical energy what we consume directly in our houses. Energy meter connected at the time of starting before coming to the power to the house, total electricity passing through the energy meter. Energy meter accurately calculates how much energy is consumed by one house or one industry, like that. Energy meter directly calculates the power V into I dt. In case of VI is nothing but P dt. Integral 0 to t P dt is known as energy. Integral 0 to t P dt. The power consumed over a period of time, if you integrate from 0 to time period t, then P dt. First we go for single phase induction type energy meter. That is very important topic. How to measure the power in single phase circuit by using energy meter. What is the energy meter construction? First we go, after that wattmeter, because already the notes was written like that. Single phase induction type energy meter we started. Power can be measured by using single phase electrodynamometer type wattmeter. Wattmeter is the instrument used for power measurement, whereas energy meter is used for energy measurement. This is the single phase induction type energy meter. Present days we are not using single phase induction type energy meter, but basic principle of energy measurement is came from single phase induction type energy meter. Presently we are in houses, we are using digital type energy meters. Digital type energy meters, how they are working, that is comes under instrumentation. Electrical energy is measured by means of energy meter, that is watt hour meter, it is also known as. The watt hour meter, energy meter as an integrating instrument. Which type of instrument it is? Integrating type instrument. Or it will integrate the value, past value with present value, it will integrate, hence it is known as integrating type instrument. And some instruments, some energy meters records the value by means of a registering system. Energy meter is an integrating instrument that takes into account of both quantities like power and time. Both quantities will be considered, the product of which gives energy. P into time, power into time is gives energy. Energy meter keeps a record of total energy consumed in a circuit during a particular period, but it does not give any idea about the variation of the rate of energy consumption during that period. Energy meters are generally of three types. Energy meters are generally three types. One is electrolytic meters, and second one is motor meters and clock meters. Three types of meters. Out of the three meters, electrolytic meters, motor meters and clock meter, it is a motor meter. It is a motor type meter. It is a motor type meter because it is a like seems to be a motor, it will rotate. Motor type. Out of the three, we are using mostly motor type meters, most commonly used meters these are, whereas the clock meters, because of their complexity, have practically disappeared from the use, although we have some applications as standard because of their inherent high accuracy. Electrolytic meters are still used to some extent. This is the single phase induction type energy meter. Mainly, what are the main parts of a single phase induction type energy meter is, there are two magnets. One is shunt magnet, another one is series magnet. What is shunt magnet? What is shunt magnet means the potential coil. It is called as shunt magnet, and the which is in series with the load, it is known as series magnet. Downward, in the downside, what we have, it is a series magnet. Why it is called series magnet? It is known as it is connected to in series with the load. Entire load current will passes through this series magnet, whereas it is known as shunt magnet. It is seems to be parallel to the phase and neutral. It is the across the phase and neutral it is connected, phase and neutral. It is known as shunt magnet. And braking magnet, it is three magnets are there totally three magnets are there. One is shunt, another one series magnet and braking magnet. What is the purpose of series magnet? Series magnet is to produce the main flux required for energy meter brake disc. It consists of a disc. Mainly there are four mechanisms for single phase energy meter. There are four mechanisms, there are four main parts. One is driving system, moving system, braking system and registering system. These are the main parts of energy meter. Coming to driving system, under driving system the shunt and series magnets will come. Under moving system means disc will comes under moving system. And braking system, in brake magnet we are using. What is purpose of braking magnet? Brake magnet is whenever power is off due to momentum of inertia, the rotations made by the disc, whenever power is off, పవర్ పోయినప్పుడు మోటార్ తిరుగుతూనే ఉంటుంది పవర్ పోతే కొద్దిసేపటి వరకు. అలాగే ఎనర్జీ మీటర్ కొద్దిసేపు తర్వాత ఆగిపోయింది అనుకోండి, మనకు అనవసరంగా యూనిట్స్ కన్జంప్షన్ ఉంటుంది. అందువల్ల బ్రేక్ మ్యాగ్నెట్ ఏం చేస్తుందంటే పవర్ పోయినప్పుడు ఆ మొమెంట్ ఆఫ్ ఇనర్షియా రెడ్యూస్ చేసి బ్రేక్ చేసినట్టుగా యాక్ట్ చేస్తుంది. మూవింగ్ సిస్టమ్ వచ్చేసరికి అల్యూమినియం డిస్క్ ఉంటుంది. డ్రైవింగ్ సిస్టంలో టూ మ్యాగ్నెట్స్ ఉంటాయి, బికాస్ డ్రైవింగ్ సిస్టమ్ ఈజ్ మెయిన్లీ shunt and series magnets. Two magnets interaction, two fluxes interaction gives another resultant flux. That resultant flux rotates the aluminum disc. The moving system comes under aluminum disc is the moving system. Braking system is brake magnet. And registering system, in analog type induction type energy meter, registering system, a gear mechanism is attached to the spindle. Whenever the aluminum disc rotates. Okay, now see, whenever the aluminum disc rotates, the brake magnet, now it won't stop because the moment of inertia as the aluminum disc is more than braking magnet. Whenever the load takes some current, some energy consumed by the load, at that moment definitely it will draw a current to the load. Definitely it will draw a current that will passes the main flux. It is phi 1 is the series magnet flux, phi 1 it is. Shunt magnet flux is known as phi 2. The interaction of two fluxes on the aluminum disc rotates the disc due to motoring action. Motoring, how the motor rotates? Whenever current carrying conductor is placed in a magnetic field, it experiences a mechanical force. Because of this, a current carrying conductor, it is aluminum disc is a current carrying conductor. Two interaction of two fluxes creates a force. Okay, the interaction of two fluxes creates a force on aluminum disc, which a torque will be, driving torque will be produces. Driving torque is proportional to energy consumed. Now what are the main parts? Again, driving system is the shunt and series magnets. Driving system, moving system, it is aluminum disc comes under moving system, a spindle attached to the aluminum disc. On the aluminum disc holes are provided to reduce the error, creeping error. And a brake magnet comes under braking system. And registering system, this spindle is attached to recording mechanism. Yes, by use of గేర్లు వాడి మనం అల్యూమినియం 600 టైమ్స్ కానీ 1000 టైమ్స్ కానీ రొటేట్ అవుతే గేర్ ఒక యూనిట్ స్టెప్ అవుతుంది. అంటే ఇక్కడ మీటర్ కాన్స్టెంట్ ఇస్ 1000 ఆర్ 600 రెవల్యూషన్స్ పర్ కేడబ్ల్యూహెచ్ అని ఉంటుంది. మీటర్ కాన్స్టెంట్ 600 రెవల్యూషన్స్ పర్ kWh. If it is a 600 revolutions per kWh, what is it means? When the aluminum disc rotates 600 times, then 1 unit will be consumed. 1 unit means what it is? 1 unit means 1 kWh. We have to remember that ఒక యూనిట్ అంటే ఖచ్చితంగా 1 kWh. 1 unit means 1 kWh. That is very important point. Okay, these are the main parts: driving, moving, and restraint system. The interaction of the two fluxes creates a torque on the aluminum disc. And another important one is there to reduce the error copper shading bands we are using. To reduce the lead lag adjustment, it is known as. ఈ కాపర్ బ్యాండ్స్ అడ్జస్ట్ చేయడం వల్ల ఈ షంట్ మ్యాగ్నెట్ ఫ్లక్స్ సిరీస్ మ్యాగ్నెటిక్ ఫ్లక్స్ ఎగ్జాక్ట్గా 90 డిగ్రీస్లో ఉన్నప్పుడు ఎక్కువ టార్క్ ప్రొడ్యూస్ అవుతుంది. అంటే మ్యాక్సిమం టార్క్ విల్ బి ప్రొడ్యూసెస్. ఫర్ దట్ పర్పస్ వీఆర్ యూజింగ్ కాపర్ షేడింగ్ బ్యాండ్స్. కాపర్ షేడింగ్ బ్యాండ్లు ఇక్కడ పెడితే ఏమవుతుంది, ఫ్లక్స్ ఇలా మూవ్ అవుతున్నప్పుడు, దీంట్లో రొటేట్ అవుతున్నప్పుడు ఈ కాపర్ షేడింగ్ బ్యాండ్స్ సప్లై ఉండదు. దెర్ ఈజ్ నో సప్లై ఫర్ కాపర్ షేడింగ్ బ్యాండ్స్. బట్ ఫ్లక్స్ విల్ లింక్ దట్ ఫ్లక్స్. ఇక్కడ 5-2 అనే ఫ్లక్స్ ఉంటుంది కదా సిరీస్ షంట్ మ్యాగ్నెట్లో 5-2 ఫ్లక్స్ పోయేటప్పుడు, ఆ ఫ్లక్స్ దీన్ని కూడా కాపర్ షేడింగ్ బ్యాండ్స్ లింక్ అయ్యి ఇక్కడ ఉండే ఫ్లక్స్ ఇక్కడ ఉండే ఫ్లక్స్కి 90 డిగ్రీస్ అడ్జస్ట్ చేయడానికి. సపోజ్ మీటర్ కొంచెం స్లోగా తిరుగుతుంది అనుకోండి, స్లోగా తిరుగుతున్నప్పుడు కాపర్ షేడింగ్ బ్యాండ్స్ అడ్జస్ట్ చేస్తారు. అడ్జస్ట్ చేసినప్పుడు మీటర్ క్యాలిబ్రేషన్ అంటారు. అదే క్యాలిబ్రేషన్ ఆఫ్ సింగిల్ పేజ్ ఎనర్జీ మీటర్. ఇట్ ఈస్ ఆల్సో నోన్ యాజ్ calibration of single phase energy meter. Finding the error in energy meter is known as calibration. Finding the error or checking the error, correcting the error, all this comes under calibration of energy meter. Okay, these are the main parts. What are the functions of every part? Function is important. Creeping aluminum disc is provided, holes are provided on aluminum disc. Brake magnet, purpose of brake magnet is to stop the revolutions. And lead lag adjustment is copper shading bands. Purpose is if slow revolutions made by the disc when power is off, that is creeping. Now the same theory we can see here. Driving system. The driving system, it consists of two electromagnets whose are made up of silicon steel laminations. Two electromagnets are current coil excited by load current, because current coil is also known as series magnet is known as. The coil of another electromagnet is connected across the supply, hence it is known as potential coil. It is also known as pressure coil in case of energy meter. The moving system, light aluminum disc is mounted on light alloy shaft. It is main part of the moving system. The disc is positioned in between series and shunt magnets. The disc is placed in between series and shunt magnets. It is supported between jeweled bearings. Two bearings we are using. To rotate freely we are using bearings, jeweled bearings. It is very small bearings. Moving system runs on 100 steel. And another thing is there is no controlling spring. There is no controlling torque. There is no controlling torque for moving system. Similarly, braking system. The braking system is permanent magnet. A permanent magnet is placed near the aluminum disc for braking mechanism. This magnet reproduces its own field. That disc moves in the field of magnet and braking torque is obtained. The position of this magnet is adjustable, hence the braking torque is adjusted by shifting the magnet different radial positions. This comes under braking system. Another one is restraint system. In restraint system, gear mechanism and registers and counters we are using restraint system. Torque equations of energy meter. Phasor diagram of energy meter. Let's assume that supply voltage is V and I1 is the current through series magnet, that is current coil. Current through current coil, that is I1. I2 is the phi2 flux. The angle between V and I1 is phi. Similarly, ISC, ISH, the interaction between shunt magnet current ISH and main flux, that is current coil or series magnet flux, produces one torque, and the interaction between shunt magnet and series field coil, that is current coil, produces T2 torque. Driving torque it is, deflecting torque not, it is a driving torque. Driving torque is proportional to T2 minus T1. if you consider this one diagram, you can understand that the interaction between phi 1 and ISH, that is phi 1 and ISH. Phi 1 is the main flux, series flux. Entire load current passes through a coil, that produces phi 1. Phi 2 is the shunt magnet flux, it is phi 2. The interaction between phi 2 and ISC, phi 2 and ISC, phi 2 and ISC, and phi 1 and ISH produces T1 torque. The torque T1, the torque is T1 is already we explained here. The torque T1 is produced between phi 1 and ISH, that is torque T1 equal to phi 1 into ISH cos of angle between phi 1 and ISH, angle versus phi 1 and ISH. Similarly, torque T2 is produced between phi 2 and ISC, that is phi 2 ISC cos of phi 2 angle between phi 2 and ISC. These two are the two torques. Now coming to the angles between phi 1 and ISH from the phasor diagram, it is 90 plus 90 minus phi, it is 180 minus phi. Now another torque phi 2 is proportional to ISC, that is equal to flux. Now TD is proportional to phi 2 ISC minus T1 minus T2. It is the interaction of driving torque is proportional to T1 minus T2. The driving torque is proportional to T1 minus T2. Sorry, T2 minus T1. Driving torque is proportional to T2 minus T1. Therefore, TD equal to phi 2 ISC cos phi plus phi 1 ISH cos phi. By substituting the above equations, TD is proportional to VI1 cos phi plus I1V cos phi. From the TD equal to K 2VI cos phi, that equal to 2K into VI cos phi, where 2K is a constant. Therefore, driving torque TD equal to VI cos phi. That means driving torque is proportional to power what we consume, driving torque. If driving torque is proportional to VI cos phi, then we can write TD is proportional to power, where TD is known as not deflecting torque, it is driving torque. If the speed is increased, when energy consumed by the instrument increases, in case of PMMC instrument, TC is proportional to theta. TC is proportional to theta, but in case of braking torque, here will come braking torque is proportional to speed. Braking torque is proportional to speed, hence we can write N is proportional to VI cos phi. Multiplying both sides. If the revolutions made by the disk increases, means energy consumed is more. That means when energy consumed by the load increases, the number of revolutions made by the disk increases. That means energy consumed by the load, it depends on the speed of the disk. The speed of the disk depends on energy consumed by load. Coming to errors in energy meter, there are various types of errors in single phase induction type energy meter. There are various types of errors. One of the error is, what are the lead lag error? One of the error is lead lag adjustment or power factor adjustment. If you adjust the shading bands, then power factor, the phase angle between two magnets will exactly 90 degrees, because the energy meter has to work for different power factors and different conditions of the load. It is possible when the flux produced by pressure coil lags the applied voltage by 90 degrees, but the iron losses and resistance of winding do not allow the flux to lag by exact 90 degrees with respect to voltage. Now you can see this is shunt coil. It is a lag coil, lead lag adjustmenting device. According to the power factor, it is aluminum disc. The pressure coil voltage, it is phi sh or phi, and this is the voltage supplied, the phi sh is. Now the angle between phi phi and phi sh is theta. Assume that theta is the angle adjustment of at the time of t. Coming to another one, that is creeping adjustment, creeping error, it is also known as creep. What is meant by creeping? In some meters the disk rotates slowly and continuously when there is no load. When there is no load means when there is no load consumed by the instrument, when there is no load consumed by customer, then it slowly rotates. The slow continuous rotations made by the disk without any current through current coil and any due to excitation of pressure coil is known as creeping. The slowed revolutions made by the disk is known as, when there is no load, it is known as creeping. What is meant by creeping? లోడ్ లేకపోయినా కూడా చిన్నగా రెవల్యూషన్స్ మేడ్ రొటేట్ అవుతూ ఉంటుంది, అంటే నో లోడ్ కరెంట్ తక్కువ ఉన్నా కూడా. దిస్ ఈజ్ డ్యూ టు ఫ్రిక్షన్ ఓవర్ compensation. Due to light load adjustment may keep the disk rotating. Light load adjustment, that is, to prevent creeping, two holes are provided or drilled on the disk 180 degrees oppositely. Two holes are provided on aluminum disk to reduce creeping error 180 degrees oppositely. ఈ ఆపోజిట్గా ఖచ్చితంగా ఉంటాయి, ఎందుకంటే ఆపోజిట్గా 180 degrees కంపల్సరీ ఉంటుంది కాబట్టి. Now what is meant by creeping? The slow revolutions made by the disk when there is no load current, when there is no energy consumption, it is known as creeping. The creeping error can be reduced by providing two holes on aluminum disk 180 degrees with 180 degrees, that means two opposite holes. By providing two opposite holes, రెండు హోల్స్ ఈ విధంగా 180 degreesలో ప్లేస్ చేసి ఉంటారు, ఎందుకంటే క్రీపింగ్ ఎర్రర్. లోడ్ లేకపోయినా కూడా, అంటే ఎనర్జీ కన్జూమ్షన్ లేకపోయినా కూడా స్లో రెవల్యూషన్స్ తిరిగింది అనుకోండి డిస్క్, అనవసరంగా ఎనర్జీ కన్జ్యూమ్ అయినట్లే కదా, కన్జ్యూమర్కి లాస్ అది. దేర్ ఫోర్ వీఆర్ ప్రొవైడింగ్, మ్యానుఫ్యాక్చర్సే టూ హోల్స్ ప్రొవైడ్ చేసి ఉంటారు. ఈ హోల్స్ దగ్గరికి వచ్చినప్పుడు బ్రేక్ మ్యాగ్నెట్ స్టాప్ చేస్తుంది డిస్క్. ఇక్కడ హోల్ దగ్గరికి వచ్చినప్పుడు మ్యాగ్నెట్ ఈజీగా నార్త్ పోల్ సౌత్ పోల్ ఇలా ఉంటాయి కదా, హోల్ ఉండడం వల్ల ఎక్కువ ఫ్లక్స్ పాస్ అవుతుంది, అప్పుడు స్టాప్ అయ్యే ఛాన్స్ ఉంది. అంటే మొమెంట్ ఆఫ్ ఇనర్షియా ఎర్రర్స్ కానీ ఏమన్నా ఉన్నా కూడా క్రీపింగ్ ఎర్రర్ని బ్రేక్ మ్యాగ్నెట్ హాఫ్ రెవల్యూషన్స్ మేడ్ అయ్యేసరికి ఒక డిస్క్ వచ్చేస్తుంది. అంటే మనకి ఒక 10 రెవల్యూషన్స్ 10 రెవల్యూషన్స్ ఎక్కువ తిరగకుండా ఈ బ్రేక్ మ్యాగ్నెట్ ఏం చేస్తుంది అంటే హాఫ్ స్టాప్ చేస్తుంది. కమింగ్ టు 2 element energy meter, 3 phase energy meter, 3 element energy meter, 2 element energy meter. One element means completely, one element means one shunt magnet and series magnet, it comes under one element. 3 element energy meter consists of 3 elements, 3 shunt magnets, 3 series magnets. Current coils, these are the 3 current coils, these are the 3 pressure coils which are connected through a common shaft, common spindle, it is through jewel bearings, common spindle it is. The connection diagram for that, it is a 3 phase energy meter. కామన్ స్పిండిల్తో కనెక్ట్ చేసి అల్యూమినియం డిస్క్లు 3 రొటేట్ అవుతుంటాయి. షంట్ మ్యాగ్నెట్, సిరీస్ మ్యాగ్నెట్. అంటే సింగిల్ పేజ్ ఎనర్జీ మీటర్ మీకు ఖచ్చితంగా కన్స్ట్రక్షన్ ఒకటి తెలిస్తే మీరు మొత్తం డ్రా చేయొచ్చు. ఇది ఆల్రెడీ ఇది ఒక సింగిల్ పేజ్ ఎనర్జీ మీటర్, ఇట్ ఈజ్ ఏ సేమ్ వీఆర్ రీప్లేసింగ్ హియర్, ఇట్ ఈజ్ ఏ 3 phase ఎనర్జీ మీటర్. 2 element energy meter means it is a, if you cut this instead of this except this, it is a 2 element energy meter. It is a 2 element energy meter. Already told you what is an element means. One element means one current coil, one pressure coil. It is one element, it is one element, another element will be downward, but a common spindle and 2 aluminum discs are provided for common spindle. This is 2 element energy meter. How to connect a 2 element energy meter? Current coil, 2 current coils are connected in 2 phases. How to connect two element energy meter, two current coils C1 and C2, and pressure coils are clubbed together. It is P1 and P2. Coming to another topic, that is wattmeters. Wattmeters are four types. For wattmeters used to measure the power directly instead of voltmeter or ammeter. There are four types of wattmeters. One is dynamometer type wattmeter, induction wattmeters, another one electrostatic wattmeters, and thermal wattmeters. Four types, but here in our syllabus we have induction type wattmeter and dynamometer type wattmeter. It is electrodynamometer type wattmeter we have in our syllabus. Electrodynamometer type wattmeter in our syllabus. Dynamometer type instrument. Dynamometer type instrument, already you know, dynamometer type instruments have fixed coils. Fixed coil is divided into two parts. Dynamometer type instruments have two parts. One is fixed coil. Fixed coil is divided into two main parts. It is divided and it is connected in a series, and one pressure coil. This is a dynamometer type instrument. One moving coil, it is also known as dynamometer type instruments like this. But according to this dynamometer type instruments first chapter లో వస్తుంది. Dynamometer type instruments ఎక్కడ వస్తాయి? ఫిక్స్డ్ కాయిల్ని టూ పార్ట్స్ డివైడ్ చేసి ఉంటారు టు గివ్ మోర్ యూనిఫామ్ ఫ్లక్స్. ద ఫిక్స్డ్ కాయిల్ ఇట్ ఈస్ ఆల్సో ఫిక్స్డ్ కాయిల్. ఇట్ ఈస్ డివైడెడ్ ఇంటూ టూ పార్ట్స్ టు గివ్ మోర్ యూనిఫామ్ ఫ్లక్స్. డైనమోమీటర్ టైప్ వాట్మీటర్ ఎందుకు వాడతారంటే అడ్వాంటేజెస్ ఉన్నాయి కాబట్టి మనం ఎలక్ట్రోడైనమోమీటర్ టైప్ వాట్మీటర్ వాడుతున్నాం. Dynamometer type wattmeter has advantages. One is uniform scale. Scale will be uniform, high degree of accuracy, and disadvantages are errors due to stray fields, serious error due to inductance of pressure coil. That is very important. Inductance due to pressure coil. Wattmeter, two coils we have. One is current coil, another one is pressure coil. The pressure coil is connected across the voltage, hence it is known as pressure coil. If the power is to be measured, the pressure coil is connected across the source, phase and neutral, or plus and minus. It is known as pressure coil. It is known as current coil. Current coil all in series with the load, hence it is known as fixed coil. It is current coil is. The fixed coil is current coil, whereas moving coil is pressure coil. You can see the diagram of dynamometer type instrument. Fixed coil divided into two halves. Two halves means two halves. Two halves, and moving coil is placed in between two fixed coils. Only one fixed coil, but it is divided into two parts, exactly half. And moving coil is placed in the spindle, and the spindle is connected to pointer. It is a dynamometer type wattmeter or dynamometer type instrument. It is the symbol of wattmeter, current coil and pressure coil. Current coil and pressure coil, it is a symbol of wattmeter, and a load is connected. And moving coil, it is known as fixed coil. Current coil is. For wattmeter, the torque equation is important. Instantaneous torque will consider. Dynamometer type instruments. In dynamometer type instrument, the instantaneous torque is given by Ti equal to I1 I2 dm by dt, because of two coils are there. Two fixed coils, one moving coil. Between two coils, fixed and moving coils, the torque will exist. Hence, I1 I2 dm by dt will be considered, where I1 I2 are the two coils currents. V is the instantaneous voltage. V can be written as V max sin omega t. It is important to note that what is the deflecting torque equation. The current through pressure coil is IPC. IPC is known as V by RPC, that is V by R resistance of pressure coil. Similarly, IPC is proportionally equal to VI root 2 V sin omega t RPC. It is therefore IPC equal to root 2 IPC sin omega t. Assume that equations are. By doing so many, it is a lengthy process to explain entire unit 3. It takes huge time, but according to our less span of time, we have to know every topic. That's why we are explaining very fastly. At equilibrium condition, TD is proportional equal to TC. At equilibrium condition, TD is equal to TC. We can substitute TD equal to TC. From that, theta is proportional to power. Deflection of wattmeter. Deflection of wattmeter is proportional to power. Theta is proportional to power, you will get theta is proportional to power, you will get from this equation theta is proportional to power. If you remove the proportionality, you will get K2 is the constant. The another important topic is errors due to pressure coil inductance. Error due to pressure coil inductance, it is very important topic. Error due to pressure coil inductance is important topic. Errors due to connection, errors due to moving system. The important one is error is due to pressure coil inductance. For error due to pressure coil inductance, we have to consider so many terms. Error due to pressure coil inductance. Wattmeter reading is given by IC, current through current coil, and pressure coil current by K cos phi dm by d theta. That is, the wattmeter reading is proportional to IPI cos phi dm by d theta. Deflecting torque equation is. From this, IPC is known as V by RP. From that, normally PT real true power will be obtained from VI cos phi by RPK dm by d theta. Similarly, considering the impedances and power triangle, from the power triangle, impedance triangle, measured power is VI. Assume that it is a RP, resistance of pressure coil, inductance or reactance of pressure coil, impedance of pressure coil. It is a impedance triangle. From that, measured power is VI1 cos phi 1 by RP by cos BK dm by d theta. By taking so many assumptions, IP, I and VL, two currents, pressure coil current, it is a pressure coil current, and current coil current is load current. From that, measured power is VI1 cos beta by RPK cos phi minus beta dm by d theta. And doing the equation 1 by 2, we will get cos phi cos beta cos phi minus beta. It is the important equation, correction factor for a wattmeter. Derivation of this also important. Based on this topic also maybe question you can expect. The error is the relation between true power versus measured power. True power versus measured power. It is known as ratio of error, cos pi by cos beta cos pi minus beta. From that, by doing this, we can write cos phi minus beta as cos phi cos beta sin pi plus sin phi sin beta. From that, if you multiply 1 by cos square beta plus tan phi sin by, you will get 1 by cos square beta. If you made common, 1 plus tan phi sin beta by cos beta you can write. Therefore, percentage error equal to secant square beta by 1 plus tan phi tan beta. You will get the equation. From that, secant square minus tan square theta equal to 1. Therefore, error equal to 1 plus tan square beta by 1 plus tan phi tan beta, where beta is the small numerator, tan square beta is very very small, hence percentage error can be written as 1 by 1 plus tan phi tan beta. And another is errors due to connections. When the current coil is connected on both sides, current coil is connected across the supply, pressure coil is connected across the source voltage, across the load. Based on that also current errors will introduce. Errors due to connection it is. In both cases, power indicated by wattmeter is power consumed by load plus power loss in current coil. Similarly, another connection, errors due to temperature. Temperature also introduce some error. Indication of wattmeter is affected by change in temperature. This is because of change in room temperature changes the resistance of pressure coil. This is the main syllabus. According to syllabus, a brief introduction about unit 3. It is very difficult to explain entire chapter in one video, but for brief idea about unit 3 is measurement of power and energy. First we discussed about energy meter. After that we discussed about wattmeter. According to syllabus, first we have to know what is wattmeter, what is energy meter. After that, what are the errors, what is the construction, and between these two topics you will get power and energy. wattmeter construction or error, one of the question, and same time energy meter construction or what are the errors. This is about unit 3 measurement of power and energy. In brief, total chapter covered in one video.